Good afternoon, everyone, and good morning. Thanks all for joining us today for our webinar, which is the third webinar in our clean energy webinar series that we started last week and will be running till the end of 2020. Our webinar today will be about landscape and future of energy storage in the MENA region. My name is Ahmed Samir, and I work as Operations Manager for the Clean Energy Business Council. This webinar is organized by the Clean Energy Business Council and co-hosted by our member Energetics. Our speakers for the webinar today will be Amit Beria, Senior Manager of Techno-Commercial at ACWA Power, and Dr. Iman Said, Head of Industrial Power and Energy Storage at Enerwhere. Before we start our webinar with Amit, I would like to welcome Dr. Nasser Saidi, Chairman of the Clean Energy Business Council, to give the welcome note of the webinar. Welcome, Dr. Said.
Thank you, and welcome everybody. And of course, under these circumstances, I hope that all of you are safe and healthy. We live in very uncertain and testing times. But as we were speaking a bit earlier before we started the webinar, at least we can look at technology to help us connect and to help us spread knowledge and keep us all connected. So although there's no physical contact, at least in the world of knowledge and ideas, we can share things. So I'm very pleased that we are organizing a series of webinars. This is an important one. This is about energy storage. As you know, energy storage plays a very important role given that we're heading towards a world with more renewable energy and trying to change the energy mix. Renewables suffer from potentially intermittent energy potential. So being able to store energy is going to be extremely important, not only for current uses, but maybe even for the future, in terms of being able to store energy over longer periods of time, not just over a day or two. So I'm very pleased that we're organizing this seminar with our members. They include ACWA Power and Enerwhere. Both of them are at the forefront in terms of introducing energy storage solutions in our region. So I hope that you'll find the webinar interesting, and also that following this, you'll consider becoming members of the CBC. As Ahmed will explain in a minute, we are an NGO and a not-for-profit organization. We're a membership organization, basically, of businesses that want to promote clean energy and clean technology across the region, across the MENA region. So I hope you'll join us in this effort, which of course is critical for the future of the region. We not only need to diversify our energy sources, but we also need to care about our environment. As the current COVID pandemic has shown, the environment benefits when you don't pollute it. We've got a silver lining in terms of COVID. It looks like, of course, that will be temporary, but maybe through the use of renewable energy and technologies, we could make it more permanent. So it is an important effort in terms of not only introducing renewable energy and storage technologies, but also in terms of combating climate change. So welcome to this. We look forward to your feedback and to your comments. Thank you, Ahmed. Can we?
Thanks, Dr. Saidi.
Thank you.
So now I'll take you through a very quick presentation about the Clean Energy Business Council. So Dr. Nasser, as I mentioned, we are a non-profit organization, and we claim to be the permanent organization representing the private sector involved in the clean energy sector in the MENA region. So we aim to establish a dialogue between the private sector and the public sector in the MENA region. We are the key organization representing our private sector who work in with renewable, clean energy and clean technology. We work on behalf of our members to promote the renewable and clean technologies through different activities and partnerships, whether with the government or the private stakeholders. So we present and develop policy papers in partnership with our members. We also provide advocacy and thought leadership for this sector. During the year, we host different workshops, events, webinars like this one to allow our members and give them the opportunity to share and promote their ideas and the projects. We also publish reports, case studies, white papers, and market surveys, one of which will be published next week about electric vehicle infrastructure in the region. We have a range of working groups, one on future mobility, another one on energy efficiency, and the third one on climate finance. And we have two special programs, one for schools and another one is women in clean energy. As of today, we have over 120 members covering very different and diverse sectors in the energy sector in the MENA region. We also work with different partners through which we either develop joint publications and reports or we organize joint events. The organizations join CBC for different reasons. We provide a platform to connect with the different stakeholders. We provide excellent opportunities for networking through our events and partnerships. And we act as the voice of the private sector, so we organize different stakeholders meetings with the government sector as well. We are a very good platform so you can promote your projects and events and different activities. As I mentioned, we have this different working groups and special programs, and this some of the activities we accomplished during last year. I'll be sharing the slides with you, but due to the short time, I'll skip this one. This is some of our events we did during the past few months. So now we'll start the webinar with Amit. So Amit, please go ahead.
Thank you, Ahmed. Am I audible well, Ahmed?
Yes.
Okay, great. Once again, welcome to all the webinar participants. So I have about 15 slides, which should be covered in somewhere between 15 to 20 minutes, during which I'll cover. Ahmed, have you given me the controls?
Yes, you can use a keyboard for the mouse.
Okay, yeah, great. It works. So yeah, so during this time, we'll essentially cover the basic of battery energy storage system as a technology and its features, its application in the entire value chain, specifically looking after its use with generation assets in front of the meter application, followed by looking at the best market globally and the dominant technology to wrap up the presentation. But first, before that, let me introduce my company. I'm from ACWA Power. ACWA Power is a developer, investor, and operator of power and desalinated water plants. We started from the Kingdom of Saudi Arabia and presently operational in about 12 countries, predominantly in the MENA region, but also expanding to Southeast Asia and Central Asia. Our total asset value is about $49 billion, which is like 34 gigawatt in power and about 6 million cubic meter per day of water projects. ACWA is a technology agnostic company, and we try to offer lowest cost of energy and water to the countries we operate in. Now moving to the topic of discussion. Just a moment, there seems to be some challenge in changing of the slides. Okay, it's back operational now. So moving to the topic of discussion, which is battery energy storage. Which in short is used as BESS. So BESS is a basically electrochemical energy storage, which converts three-phase power to DC reversibly, of course, with the associated losses in this round-trip conversion. There are three major parts of a BESS system, which are shown in the image on the right side under three color codings. The main component is the battery in itself, which stores the energy electrochemically. The second component in the middle, the yellowish part, is the power conversion device, which converts DC into AC and AC power into DC. And the third is the grid interface and protection component. Now, this portion of the grid interconnection and protection is a very standard one, has been used across technologies. On the power conversion part, thanks to the progress in the PV sector, the power conversion has been improved to be very efficient and quite standardized. On the battery part is also a mature technology and significantly deployed globally. We'll see towards the end of the presentation in one of the slides. But still, the amount of investment in the R&D and the innovation on the battery part is significantly ongoing. So which leads to significant improvements in the near future on the battery DC part itself. Now, coming to the features or the functionality of BESS. BESS is a very fast responding device or system. It can go from 0 power to rated power in a time frame of seconds, right? And which is something which grid operators look at in order to manage the grid. Second is that it is very flexible in nature, so it can function as a versatile use case. Why is it flexible? Because it can have dual role as a load as well as a source. So the grid operator or the power plant, it can have dual functionality, which gives to a lot of flexibility. Now, owing to this unique feature of BESS, I think there is some lag in change of the slides. Okay, now it's there. Okay, so owing to this unique feature of fast and flexible nature of BESS, it finds its application in the entire electricity value chain, starting from generation, transmission, and distribution to the behind the meter application for residential, industrial, or commercial customers. But for today's presentation and something which is aligned with ACWA's business, we'll specifically talk about the use case of BESS with renewable generation plants. So specifically on the generation side of things. Now, PV is one of the fastest growing renewable energy technology, owing to its many advantages, lowest cost of energy,
Do you need to change slides?
Yeah, Ahmad, I think there is some issue with the change of slides. So if you could operate it for me, if you can go to the previous slide.
Sure.
Right, thank you. So yeah, so maybe I'll just give you a cue for change of the slide. Sure. Thank you. So yeah, so solar PV is one of the fastest growing renewable energy technologies, owing to its many advantages, specifically lowest cost of energy, relatively simpler engineering, relatively simpler O&M, faster deployments, modular in nature, and so on and so forth. But as the penetration or the proportion of solar PV or wind for that matter increases in the energy mix, there are certain challenges which come up for the overall power system, which needs to be addressed, which we'll look into details in the coming slides, but which are like high ramp rate, infirm generation, reduced inertia of the overall power grid, and low capacity factor, which means lower utilization of the transmission assets. Now, specifically looking into the high ramp rate in the next slide. So the figure on the left-hand side shows a typical grid load curve in this region, in this part of the world. So if you notice, the peak load happens during the daytime, which aligns very well with the PV generation curve. So PV can take care of the peak load as per the current load demand of the region. On the right-hand side, the plots show a scenario where a significant amount of PV is added into the energy mix. So the blue curve shows the load curve as it is, the grid load. The orange shows the PV if a significant amount of PV is installed. The dotted blue shows the load curve once PV has been added. So this dotted blue is something which needs to be catered by non-PV generation assets. PV takes care of the daytime load, but there are 3 points which needs to be taken care of. Let's say 2. One is that the evening peak load still remains unmet. Second, when the PV generation drops down in the evening, let's say from 5 to 7 p.m., the ramp rate required by non-PV generation assets is very steep, so which creates a strain on the network and on the power plants as well. Now, if we add BESS to a PV power plant, the expected load curve. Now, BESS is a very dispatchable technology, so it can be made to dispatch in any wanted manner. But choosing one of the dispatch patterns, the remaining load is shown in the green curve here. So if you see, the ramp rate can be significantly reduced by adding of BESS. That's number one. Second, some amount of an evening peak can be catered by by BESS in integration with PV. The third, that if a very large quantity of PV is added into the peak, then the PLF of the non-PV plant reduces significantly. By addition of BESS, this can also be handled to certain extent. Moving on to the next issue, which I mentioned in the previous slide, is mentioned in the next slide, which is the variability of PV. Now, PV inherently is variable in nature. In the shorter time scale, it has infirm behavior. Now, the ability of a grid to handle such infirmness depends on the type of loads that are connected, on the non-PV assets, generation assets that are connected, and on the grid strength in itself. But as the proportion of PV increases, the inertia of the grid reduces, and hence its capability to handle such infirmness reduces. Now, once BESS is integrated along with the PV, it can help smoothen this short duration, sharp fluctuations in PV, which is depicted pictorially in the left-hand side graph here. So let's say if there is a sharp drop in PV, BESS can complement that, and from the grid interface point of view, it's a relatively smoother curve. Right, and it does not mean that we need to have two separate BESS systems for the ramp rate management and smoothing. It can be the same asset with certain allocation of energy for both the use cases, and both can be done with the same asset and optimization can be achieved. The third issue raised was the capacity factor, right? So PV generates when the sun shines. Now, for a given transmission capacity, in the next slide, please. For a given transmission capacity and a given export limit, there is only so much of capacity factor that can be achieved. But once a BESS is added, the PV installation quantity can be increased beyond the grid export limit. It can be stored in BESS, and it can be dispatched during non-solar hours in the evening to cater to the challenges of, let's say, evening peak, ramp rate, or any other factor as required by the grid. But in overall net, for the same grid export limit, the capacity of that plant can be increased. Hence, more utilization of the transmission infrastructure, of the medium voltage to high voltage substation, and so on and so forth. Now, all these three situations are very well aligned with our region here. If you go to the next slide, most of the countries in this region have set very high renewable energy targets, which means sooner or later, these challenges will have to be addressed. Now, BESS has the capability to serve all these applications in a stacked manner and thereby retrieve more value out of the investment. And utilities in this region have actually started incorporating BESS, already started using them. For example, Abu Dhabi already has about 600 megawatt hour of installed BESS capacity distributed. Dubai has 2 plants of approximately 8 megawatt hour each, and Dubai also has the largest thermal storage. Although thermal storage is not the topic of discussion, but there is a largest thermal storage here being constructed by ACWA, 700 megawatt, 15 hours of duration, and so on. The next question comes is economic viability. So many of these applications are already economically viable and competitive, but we'll see in the coming slides that the battery pack prices are on a downward trend, and as it goes further down, more and more applications become competitive. If we look at the global market, already about 6 gigawatt hour of storage is operational, which shows that a performance track record of BESS already exists. Now, let's not look at the exact number of future predictions of BESS, but all I wanted to give you a view here was that BESS installations are predicted to increase on a very sharp rate. Different consultancies or different organizations have different predictions, but it is definitely on a very pretty fast increasing trend because of the renewable energy price decrease, because of battery price decrease, and so on and so forth. Now, within the BESS system, the battery technology in itself can be varied. There are many technologies available: lithium-ion, flow batteries, sodium-sulfur, sodium metal halide, and some kind of advanced lead acid as well. Now, each technology has its role to play in this BESS integration globally. But still, the dominant technology, which I think will be lithium-ion battery, and in at least in the near future, one of the main reasons for that is the dominant technology in grid storage. If you go to the next slide, please. The dominant technology in grid storage will at some level be influenced by the technology adopted in electric vehicle. The reason for that is the consumption of batteries in electric vehicle is way higher than the consumption of batteries in grid storage. So which means the benefits, the economies of scale, which is achieved by users of battery in the electric vehicle will trickle over to the grid storage as well. So once again, each technology has its role to play. They will be adopted at certain scales for certain applications, but lithium-ion could be one of the dominant technologies in the near future. The graph on the right-hand side, again, let's not look at the absolute numbers because the battery pack prices are influenced by many factors, the C rates, the applications, the life, and different agencies have different prediction methods. And so you can see that there are varied dots, absolute numbers for each particular year. But the overall trend is similar, that the battery prices are on a sharp decreasing trend. So which again coincides with my previous comment that in the electricity value chain and specifically with the generation plants, already many of the applications are economically feasible and economically competitive to other technologies. But as the battery prices are decreasing, more and more of such applications are getting added to the economically viable list. Going to the next slide. So just to wrap up the presentation, the key takeaways from me would be BESS is a fast and flexible technology, and hence it finds its use case at each level of the electricity value chain and at an economically viable way already. And with the decreasing price, it becomes even more competitive. With increased in PV penetration, integration of BESS will help mitigate all the challenges associated with it. In MENA, region, we are very bullish on this technology use case, and already the utilities in this region have adopted or have opened up to adopt it in terms of testing or in terms of asking for such proposals in the upcoming tenders or projects. So it is already being integrated very well in this region. And BESS is already a mature technology. It has a significant performance track record globally, and which is on a sharp increase in the years to come. So with this, I think I will end my presentation. Over to you, Ahmed.
Thanks, Ahmed. Very interesting. So I just want to remind everyone in the webinar that please feel free to ask any questions you have. You will find the questions section on the right-hand side, and we'll be taking questions by the end of the webinar. So now in the next presentation is Dr. Imran Said, Head of Industrial Power and Energy Storage at Enerwhere.
Hi, Ahmed. Can everybody hear me right? Can you hear me?
Yes.
All right. Thank you, Ahmed, for a great presentation. I think that sets the stage very well for what I'm going to be talking about today. So essentially, I think Ahmed gave a very good overview from a developer perspective about and also about on the utilities side of things, how storage is moving along, right? I will be talking a little bit about storage in the beginning, and then following that up with some live real world examples of how we've implemented a few of these projects and some of the learnings from those, and where we do think the gaps are right now in getting the storage systems implemented, and where there is a role for some players to come in and bring in some expertise on that, right? I'm just trying to see if I can move the slides. I think, Ahmed, it might be better if you do the same, because if I click, it doesn't seem to be moving. So let me start with a bit of an introduction to Enerwhere. Enerwhere is what we like to call one of the first distributed solar utilities in the world. What we do is essentially we have different parts within our company, but our core is essentially we set up off-grid hybrid systems, mostly in the UAE and some in the Middle East, essentially, which includes solar diesel battery systems that then sell energy to the clients, right? We do it at a zero capex model so we're basically a hybrid project developer in that sense. And we've got around more than 30 projects right now in the UAE, where we've been replacing diesel generators with solar diesel or solar diesel battery systems. Now, why is this important, and where does storage fit in here? I'll talk about it a little bit as we move on, right? If we move on to the next slide. Yeah, so just to repeat what Amit said a little bit, right? Like, energy storage is playing an increasingly large role, right? And especially with increasing renewables, the grid is going to need a source of stability and a source to sort of smoothen the curve and do all the applications that Amit already spoke about. And we do see this boom in the last few years, and especially over the last couple of years, there seems to be a real interest in energy storage, as is also quite evident from the number of attendees here who want to understand this technology better, right? So what we've done at Enerwhere over the last couple of years is because going back to the hybrid systems are essentially, for me, they're like a playground for a larger grid, right? Because some of the issues that you see within a hybrid system are essentially repeated on a larger scale in time, because the cost of power on a diesel generator system that's available. If you can move on to the next slide, Ahmed, I think that'll be good. Yeah, so let me talk a little bit before going into that about the Middle East and what storage is there, in the sense that I think Amit already spoke a little bit about a bunch of projects. Now, Enerwhere has done a bunch of smaller projects in Dubai on our own grids, and we've also got there are a couple of real big projects going on in terms of pilot projects of 7.2 and 8 megawatt hour scales. One of those projects is being done by Enerwhere, and I will speak about that a little bit as we move on. There's also within Sharjah a couple of small pilot projects that are going on. These are not usually out in the market in the sense that people do not really know about it, but these are pilot projects that we've been implementing. And I'll set up a few examples as we go down in case studies and explain to you what the applications were and how those things moved on, and how those things were set up. Moving on to the next slide, please. Yeah, so this is where I was talking about earlier, right? In hybrid systems, essentially what you see is a sample or a screenshot or a snapshot of what you see on a larger grid. The advantage of being in a diesel generator based system, for example, is that the cost of power on these systems is much higher. So in the sense that because this of course depends on the cost of diesel, which is currently coming down, but it's still expensive, right? You could have grids around the world that with the cost of power is close to maybe 30 cents per kilowatt hour, which is way higher than what you would find on a utility scale grid. Now, because of the cost of power being that expensive, technologies like solar are more viable there even before they were on the larger grid, right? Because what you're replacing is essentially expensive power. And following that same logic, in order to increase the penetration of solar on these grids, the same way that you need storage on the larger grid, you would start looking at storage in these grids a lot earlier than you would on a larger grid, which is what Enerwhere has been doing over the last couple of years. So it's sort of a snapshot, and you will see examples as we move on about these smaller systems and how they operate, and some of the applications that Amit spoke about earlier. I'll show you a few graphs that show how these things operate, and we'll talk a little bit about those systems and how these things operate. Now, to understand a little bit in detail about the supply chain for these energy storage systems, right? When a developer or an end user essentially goes out and looks for a containerized ESS, there's a lot of components within there, which Amit touched upon briefly as well, right? It's not one supplier that supplies the whole thing, right? It's usually a bunch of suppliers that then get bunch of components that then get integrated by one supplier then and sold to the client. So within a containerized ESS, you will obviously see the power conversion equipment, which converts DC power to AC power. Then you have the battery racks that essentially take cells from specific suppliers, put that into racks with a BMS, and then that gets connected to a power conversion system, which then gets put up in a container and then sold to the end user. Now, within this, there is a way that Enerwhere has been looking at, and I think globally countries and companies need to start looking at is can we go a little bit down that value chain? You need specific expertise to be able to do that, but then if you're able to go a little bit down at the component level and containerize systems yourself with certain inbuilt expertise, I think the cost of power can drop down dramatically, because at the battery rack level, right, the cost of dollars per kilowatt hour has been dropping quite dramatically. Now, on top of that comes the power conversion equipment, which as it grows is also a separate cost component. Now, the battery rack with the BMS comes at a price of, let's say, 150, 200, $250 per kilowatt hour. On top of that, you add the power conversion equipment, you add the controllers, and you put a container around it, and there is then the full system. Now, if you're able to do these things locally within the MENA region and give that opportunity to companies that can put that together, I think we can dramatically bring that cost down and be able to set up systems that because the cost of dollars per kilowatt hour is sometimes what determines the economics of the site. So there is a real opportunity to be able to do that, and we've been doing that in the last couple of months, to be honest, where we've been trying to bring in and bring up our own containerized energy storage systems locally. If we can move on this to the next slide. Yeah, so just to talk about what I was saying, right? There's these battery suppliers, the cell suppliers, there's Panasonic, there's Samsung, who supply some of the cells, right? And then companies like Tesla take that over, and then they develop a full integrated system. And then there's a bunch of people in that range, and there's a bunch of people who develop the software on top of that. Now, what we've been looking to do at Enerwhere is to go deeper down that chain, right? Battery rack with BMS, there are a lot of large companies around the world that do it, like Panasonic, there's CATL, there's Narada, there's a bunch of guys who've got the expertise and the scale to do that. And there's a bunch of power conversion system suppliers, right? So bringing that together and developing the software layer on top of that can be something that can be done by localized companies, we believe, bringing the cost down and also ensuring that there is expertise regionally to be able to install these things. Moving on. So I'll talk a little bit about a few examples we've done and what we've been doing over the last couple of years, right? So we've been trying to develop that software layer that ensures that a system considering of diesel generators, batteries, and solar comes together to form to form a grid that has a high penetration of renewables, and that can essentially be a snapshot of what you will be seeing on a larger grid. Now, key to this is, for example, usually the batteries or the BESS comes with, there's a BMS, which is the battery management system, and its own control system, right? Then there's a solar part of it, which has its own inverter. And then you've got the diesel generators that have their own controllers. Now, putting these three things together, there isn't a lot of software out there, or there's very limited number of companies. So what we've been doing at Enerwhere is developing this Enerwhere, what we call the inside control system, or an energy management system that makes sure that these three things operate optimally. which is right now a gap, right? The battery suppliers will give you a system that's got its own control system. The generator suppliers or the solar inverters have their own control systems, right? There's nothing that there isn't a lot of expertise or management systems that bring these things together to operate optimally, which is sort of what we've been doing at Enerwhere, and which I think is a gap that still exists in this market, even at the grid scale, which I will explain later. And we've been trying to close that gap actively. Can we move on? So the first case study is one of a small site office that we have operated in Dubai, on which doesn't have a lot of solar, but we've been using the BESS or the battery systems to do certain applications on that grid, which we'll talk about, right? In a sense, this is a system that's got, it's a site construction site office operating in the middle of Dubai, right? It's got around 40 kilowatts of solar there. We've got 2 large generators, and we've got 1 Tesla power pack system. This was installed in late 20, I think mid 2017, right? It was one of the first BSS lithium-based BSS systems that was installed in this region. I think it's the first Tesla power pack to be installed, at least. And it's the first microgrid that's operating on a BESS. So here the battery forms 2 or 3 specific applications. If we can move on to the next slide. Yeah, so you can see one of the applications, this is actual real data from operating sites, right? So the diesel generators essentially operate better when they've got a very flat load on them, and when where they're loaded optimally to have best efficiencies, right? So one of the applications that we use the batteries here for is essentially to do peak shaving, which is very similar to what one of the applications that Amit mentioned earlier on the grid as well, right? Where we ensure that there is a very flat load on the generators themselves, improving the efficiency of the site. That's one application. And then when we have enough solar in the morning and we've got a fully charged battery during the evening, we simply switch over. This is not something that's happening on the grid now. It might not happen for a while, but this is a scenario where we've been able to switch off all other generating sources and run the batteries through the night, supplying all the loads. So this essentially improves your efficiency of the system, and if it allows you to increase your solar penetration beyond what your load is, right? I hope at some point time in the future we'll get to that stage at the grid level, but this is a very unique application where you can see peak shaving and you can also be able to run the grid on batteries. For this, you do need a PCS that's able to form a grid and specific capabilities, and some of the challenges you will face here are also in terms of transitioning between different sources of generation, which is where the controller plays a very critical role here, right? Because it looks at all the sources of generation, ensures there's a smooth transition, and we go into concepts like group control, etc. And the PCS itself is very critical over here. The batteries are quite standard globally right now, right? But the PCS part of it is still, there's still limited suppliers, and the technical capabilities of these suppliers vary. So there is a lot of standardization to be done here to be able to bring in these applications, and I think that will get standardized over the coming few years. If we can move on. Yeah, so this is sort of an interesting case study again, about an industrial load that's operating in Sharjah. It's again a microgrid that's got very peaky and very unstable daily loads, and we've put in a lot of solar on this site. If you can move on to the next slide, I can give a brief update. Yeah, so it's in Sharjah. It's an industry that's got big baling machines that have a lot of crazy peaks, right? Now the load on this site is close to around 150 to 200 kilowatts, right? And we've been able to put up to 300 kilowatt peak of solar on this site. So you see the penetration of solar during the day is going to be quite high. It's almost at the level of where the load is. We've again used Tesla power packs here. They're quite easy to use, and it's a pretty good product in what we've experienced, right? And we've put that in there, and we've got our own control system to be able to manage this system, right? It's a very nice snapshot of what we will see on a larger grid. If you can move on. Yeah, so this is an interesting graph, right? You will see during the day at the top that the load is a blue line that you see there, and our solar is almost at the load line there. Now, this is not a very high resolution, what you see on top there, but if you look at the bottom graph, that shows you a very good snapshot of how those peaks and those curves look like. Now, the load fluctuates here by up to 100 kilowatt over 1 or 2 seconds. Now, I will not be able to put in a lot of solar in here unless I have something to stabilize that grid. Now, most microgrids globally cannot penetrate as much solar as we are doing here, right? Because one of the major reasons is, of course, because you don't have anything to stabilize that grid, right? If I have solar there and you have a very largely fluctuating load, my source of generation cannot take in that power and cannot handle that reverse flow of power, right? Now we're using the batteries here for mainly two or three things, right? One is, of course, frequency stabilization. Before we got onto this site, the frequency of that this client was operating at was varying between 49 and 51, right? Because of those crazy peaks and the generators not being able to hold that frequency. The batteries have been able to improve that dramatically, and we've been able to move from that range to maybe 49.8 to maybe 50.1, right? We've brought that in closely. Secondly, it's allowed us to increase the penetration of solar without having to curtail it, right? So we've been able to, so you see the solar keeps moving around with the load, and any excess solar is easily absorbed by the battery, limiting the amount of a curtailment that I have to do. So the battery manages this grid in the morning, and you can see at night that even with the choppy loads over there, the solar is able to charge the battery throughout the day. And during the evenings, you're able to see we basically switch off the generator completely, and that excess solar is then used to supply the load at night. The economics of these things are currently viable, partly because, as I mentioned earlier, that the generator is an expensive source of power, right? That does depend on two or three factors, of course, which is the diesel price, the price of batteries, and essentially the cost of setting up that system, right? But this will vary. But globally, there are a number of microgrids, especially in countries that do not have subsidized diesel, where the batteries are beginning to make sense. And it's a good snapshot of what we're going to see in the future. If we can move on to the next one. Yeah, so this is a unique case study of a site that's operating out in Abu Dhabi. It's a landfill site it's a landfill operation site in Abu Dhabi that wanted to be a little bit sustainable, and and it's a little bit remote and far away, and they wanted to take this site completely on solar as much as they could. So it's a very if you can move on to the next slide. Yeah, so essentially here we've taken a different approach, and I think it's a good time to talk about the different technologies of batteries out there and what we've done. So you saw the first two projects were based off of lithium ion, and even within lithium ion there is two categories, right? There's lithium ion NMC, which is what a lot of companies like Tesla, etc., use, and that's commonly used in cars because this is more it's a more dense technology and requires less space. In this sort of project, we went with lithium iron phosphate, which is there's a bunch of suppliers from China that have that capability, and that's slightly not as dense, but it is a little bit bulkier, but it is also safer in a sense that it's less prone to catch fire, essentially, right? So here we've gone with a lithium iron phosphate technology. The loads are quite small, and there was enough space to throw solar on the ground. So we've gone with this 150 kilowatt peak of solar, around 200 kilowatt hours of storage, and around 150 kVA of DGs. If you move on to the next slide. So here we've been operating, it's one of the few examples probably where we've been operating during the winter. We're almost operating completely on solar and battery systems. The generator does not come on at all. You can see during the early morning period, essentially the solar charges the batteries up quickly and the batteries discharge throughout the night. In summer, because the loads are slightly higher, right? So there is some generator coming on during the night, especially when the batteries start to run out. But it's an ideal example of where we would all hopefully like the world to be in a maybe hopefully a couple of decades at least, where we're able to source or so the idea is that storage does make this possible, right? It is possible to run a grid completely or at least 90% on solar. And on a small snapshot, we've been already doing it. Now on a larger grid with the same technology, right? Because these are standard boxes that can scale. If you go to LFP suppliers with the PCS or to lithium ion from Tesla or anybody else, these things can be scaled. What you're seeing here on a small snapshot can be repeated at the grid scale. If we can move on. Can we go to the next slide? Yeah, so I'm going to talk finally about one grid connected energy storage project that we've been doing. It's one of the projects that Amit did mention in his presentation. This is essentially a 1.21 megawatt, 8.6 megawatt hour storage system that's being implemented. It's a pilot system that's being implemented in Dubai, which is under construction right now. And I want to talk a little bit about the applications and what sort of where the gaps are in terms of connecting to the grid and enabling a system to perform. Now, as I mentioned earlier, right, I think one of the cases or places that needs a bit of standardization from the experience that we've gained is the control systems that each battery supplier comes with, be it the West or be it the East, is very different to each other, right? The capabilities of what is in there is very different. And then when you're connecting this to an existing grid, be it a generator grid or utility grid, they have their own SCADA systems and their own control systems. Now, to find the match or to be able to 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 control this battery system from the existing SCADA and to bridge that knowledge and to bridge the capabilities there is a gap that is currently existing from what I see, right? because there is, like Amit mentioned in his slide, there is a SCADA, there is PLC, and some of the batteries have some capabilities in terms of they're in themselves smart, or they need an additional control layer on top to be able to tell the batteries to do something. And that is the gap that is currently existing from what we have seen, be it off grid or on grid. And there is a bit of confusion, I think, around that. And we're hoping or working with battery suppliers and also with grid operators to be able to fill that gap in the middle and to be able to create, there is, I think, a small software layer that is required between the battery systems and the grid or diesel generators that can smoothen out this process. And this has been it's quite exciting to be involved in these projects, right? These are pilot projects where there's a lot of learning to come from, to take. And I think as this becomes standard and as the grids learn, that's our experience, right? As the utilities learn and as the battery suppliers learn what is needed, there is a lot of potential here. And I think we'll get to a standard position, but we do need more companies that locally also, I would say, that know the local market well, that know the local requirements well, that can sort of help integrate these systems into the grid or otherwise. That's a brief overview of what I wanted to talk about. I think the key takeaways are that the storage is important. Storage is going to continue to grow. We've already tried it. We've already tested it. There is a layer, or there is a gap within there that needs to be plugged in. I still think, between the developer or the end user and the battery suppliers, and that role will grow. And I think as things get standardized, it will continue to get better. But it works. That's our experience over the last couple of years. It will continue to grow, and let's hope that more people start looking at this technology and putting it out there, especially as it becomes more economically feasible. Thank you.
Thank you very much, Dr. Aman. That's very interesting. So now we'll try to take a few questions. We actually have more than 40 questions came through, so I don't think we'll have the time to take all of them. So we'll try to take as many questions as we can till the time ends. So the first question we have from Bavin Verma is asking, what's the future of sustainable and cost-effective energy storage like thermal and hydro in the MENA region? So Amit or Dr. Aman, please feel free to answer.
So can you repeat that? I didn't hear that exactly.
What do you think is the future of sustainable and cost-effective energy storage like thermal and hydro in the MENA region?
In my opinion, I think, as Amit said, I think the electrochemical-based storage is going to take the lead, partly because the requirements globally are much higher, especially due to electric vehicles, and the cost position of these systems is going to continue to come down. But I will let Amit answer a bit, because I know ACWA has been developing thermal storage as well. So I'll just leave it over to him.
Yeah, I mean, I concur with the thoughts of Dr. Imran. Basically, thermal storage will have its role to play in this region. Hydro, unfortunately, I don't have very much information, so I won't be able to comment, but thermal storage will have its role to play in the region, depending on the application required. So for example, the Dubai plant that we had built was a base load plant with 15 hours of storage. Thermal made perfect sense there. Electrochemical storage is not yet there to make sense. Probably now, probably in a couple of years it will reach there. So it depends on the application really, but electrochemical storage will definitely have an edge in a larger portfolio of applications.
Thanks, Amit and Dr. Aman. So the second question we have, someone is asking, as a developer or investor, what do you think is which would be the best battery energy storage system, the most profitable one? Is it DC or AC or something else?
Yeah, I mean, if I can answer to that, I think it depends on multiple factors, right? First is, what is your application? What is your exact application? Right? Are you looking to do time shifting? Are you looking to cover peaks? Because it depends, and based on that, you will have different C rates, right, or different characteristics of the battery and lifetimes. So you need to look at that. Now, I do think that the future is most likely, if you're looking at PV plus BSS, a DC coupled system makes sense, right? Because you gain some efficiencies there, where the PV and the batteries are essentially coupled on the DC side, right? Because if you look at most of these, the battery, and we've done the project that we did in Abu Dhabi is a DC coupled system, right? You've got hybrid inverters that take both. So I think, I'm not sure what the questioner means, but if you're talking about DC, you're not going to be able to connect DC to the grid straight, but DC coupling on the storage and PV side does make sense.
Thanks. So the next question we have from Alawi Midher is asking, are battery sufficient to handle all the storage need for 100% renewable grid, given that batteries are incapable of storing power for a long period of time?
Do you want me to take that?
Yeah,
Sure.
I mean,
Please.
Okay, yeah, I think it's a misconception that batteries are incapable to have storage for longer duration of time. So if we want to have like a base load plant with batteries and any renewable source, it is very much possible today. But the question remains is whether it is economically competitive against any other technology, be it thermal storage or be it gas based or be it anything. So maybe as a base load plant, it will have to be seen from region to region, because for example, if a region has very high PV capacity factor, and limited seasonal variation, it could make sense even now. Whereas for other cases, maybe if the project is commissioned 3 years down the line or 4 years down the line, it would make sense. But we also need to take into consideration that the construction time of larger projects, specifically utility scale, let's say front of the meter, is let's say 2 years. So considering that, yes, for sure, very soon, I think we will see that longer duration. Just to give you another example, previously storage used to be used probably for 15 to 20 minutes just for smoothing. And currently we see a trend of it being used from anywhere between 2 to 4 hours, and also projects from 4 to 8 hours. So the duration of storage has been increasing over the years, and I see it to be increasing further in the coming years.
Okay. Thanks, Ahmed. So the next question we have from Kashif Sheikh is asking, does battery energy storage systems equipment have to be pre-qualified?
I think there is sort of a gap right now in the sense of in the grids here. It's not very clear. I don't think there is enough regulation out there in terms of what is, like, for example, for PVs we have a clear list, right, of accepted equipment, but for storage that isn't available, that isn't there yet. It's more because most of the projects here, at least locally, are being utility driven, right? So the utility makes a choice of what equipment to use, unlike solar, where clients can basically install their own systems. What we have done within Enerwhere is, because we are on the off-grid systems, those we do not have too many of those regulations there. So you have to do your due diligence if you're installing a battery project, especially at a smaller scale, and the utilities are doing that, right? They're doing factory acceptance tests, they're going out there, talking to the people, getting the technologies right. But there isn't a clear set of guidelines from the utilities here, I think, on what technologies are there, because it's not been opened up to private companies to be setting up these systems yet, right? It's very utility driven, where somebody comes up with a proposal, they go through the technicalities, and then they say yes, this works. What we have done, for example, on the 8.6 megawatt hour project, is we've had to follow some of the guidelines for PV inverters in terms of harmonics allowed, etc., and prove that the battery PCS conforms to those regulations. So that's sort of been the shortcuts for now.
Thanks, Dr. Aman. So I think we can take 2 more questions. So the next one from Nuaj Menz is asking, do you see high temperature as a challenge for lithium-ion batteries in the region? And if yes, what are the competing technologies? Maybe nickel cadmium, or what else?
Not sure I got that, or Ahmed can take it if you want.
He's asking,
Yeah,
is high
so-
temperature a challenge for lithium-ion batteries in the region?
Right.
And if yes,
Not
what are the
really.
competing technologies?
Yeah, so lithium-ion batteries generally have a very temperature-controlled environment by use of either liquid cooling or forced air cooling temperature. So yes, there would be certain auxiliary consumption which will be higher compared to a region where temperatures are very low. But in terms of the overall life or performance, it's not at all a challenge. Of course, the efficiencies might be slightly impacted compared to different parts of the world. That's it.
Yeah, I think I can add to that quickly, because we've actually had projects running here for the last couple of years. What we do see is probably some increased auxiliary consumption, but the efficiencies that are on the data sheets for these systems, be it LFP or be it lithium-ion NMC, have been largely met, right? We haven't seen like a large drop in round trip efficiencies because of the weather. We've operated the batteries outdoor here at 50 degrees and they still seem to function. So we haven't, in 2 years of operating these things, we haven't seen much of an impact. So I think these things are pretty well engineered. You do need to maintain them at a good temperature. And in that sense, also the difference between LFP and NMC matters, because I think LFP is more durable and can take slightly larger temperatures. So I do think LFP is the way to go, especially for stationary storage. Lithium iron phosphate, I mean.
Mhm. Okay, great. So I think the last question we can have for today is from Cyril, is asking about the environmental impact of when you choose the battery technology. Do you consider that? And if yes, how do you evaluate the impact and how do you minimize that?
Yeah, if I may, I think the environmental impact question comes from the recycling point of view towards the end of life of the battery. So, because during operation, there is no environmental impact, at least. Okay, I think it's a very generic statement. For certain technologies, there is, for let's say lead acid batteries, but the predominant technology used for grid storage currently is lithium ion. So my answer is with respect to that. During operations, as such, there is no environmental impact directly. Of course, the point of discussion generally across forums is what happens at once the end of life is reached for these batteries. So, contrary to the normal opinion, there is enough recycling facilities around the world available for lithium-ion battery recycling, because lithium-ion has been used in consumer goods like power drills, mobile phones, etc., which generate enough e-waste already. So the only thing that needs to be taken care is to incorporate proper procedure to recycle the batteries, basically decommission and send it to a recycler and get it recycled in an environmentally sustainable way.
Yeah, and I think just to add, the market will take care of that. I don't think we have enough storage that have reached the end of lifetime yet, but this will increasingly grow. I think as that increasingly grows, and maybe 5 years down the line and 10 years down the line, when you have this massive lithium, I do hope that the world stands up to it and figures out ways of recycling it, if they have not already completely done it.
I think it might also include the different production techniques. Do you look at the production and how these batteries were produced when you choose them?
No, I think production, I think another point of discussion which comes is the mining of some of the materials in itself. But I think as far as the grid storage is concerned, the technology is moving more and more towards LFP, and even globally, due to the awareness, even the mining, the point of discussion of mining, which is not environmental friendly, is moving towards a process or a method or under the conditions which are moving towards being more environmental friendly. But I think it is more, yeah, it is a discussion point mainly for NCM chemistry.
Yeah, agreed.
Okay. Yeah. Okay, thank you so much, and thanks for everyone. I think we have too many other interesting questions, but due to the limited time, we can't really have answer all of them. So please, if you have any question, please feel free to email me at this email you see on the screen, and I'll make sure to have it answered from the speakers. So I thank you again, and thanks to our speakers. And we have our next webinar will be on 21st of this month. Will be about the effect and the impact of the COVID-19 on the energy sector. So it would be our pleasure to have you again. So thanks for listening and watching, and hopefully to have you on next events.
Thank you.
Thank you.
Thank you.